in, and here's the story here. Test the series for convergence here. Now, what's the story about this? What series is this? It looks to me, I can describe this as what? I might have to start at n is 2 to infinity, but we need to alternate. So this will be -1. Let's see if it makes sense. If I put no, I can put n. Yeah. Now notice this. The first term, this is when n is 1, or not 1. We're starting where? At 2, n is 3, n is 4. Okay? Is this series alternating, by the way? Say what? Yes. Positive, negative, positive, negative, positive, negative. And then this is going to be the alternating mechanism. Now, I have to know something about this. This is the Bn. Okay? 1 over the natural log of n. So hopefully Desmos is still here. Natural log what do you guys notice about this particular series? Starting at what number? Do you guys see starting at 2? Starting at 2, what's happening? We're decreasing. Is that true? All right. And are the terms all positive? Yes, they're above the x-axis. All right. So Bn is positive. Bn is what? Decreasing. What do you have to show? The limit as n goes to infinity of 1 over the natural log of n. What does this actually equal? That's a 0. Is that true? Because we know as n gets big, the natural log of n goes to infinity. So the ratio of 1 over the natural log will go where? To 0. This is a justification. This is what you're seeing now. So more importantly, what do we know? This series what? Converges by what? Alternating series test. Okay. Next example. What do we know about this? That's alternating, is that right? So what's our Bn? Okay, isn't Bn positive? Yes. And Bn is decreasing. Is that true? Do you guys know how we can see how that's decreasing? Let me share this with you guys. Isn't the square root of n increasing? This denominator is what? Increasing. But what's the deal? 1 over a denominator that's getting bigger will be what? Decreasing. Is that true? So I know the terms are positive. they're decreasing. If you said, can I see that on the graph? Okay, maybe. We've been having fun with this stuff. At least I have been. You can see my point. All right, you guys okay with that? Can you see that there? Maybe I have to, starting at 1, decreasing. All right. What do we have to do? We're going to take the what? Limit as what? As n goes to infinity of 1 over the square root of n, which equals what? 0. Why? Because as n gets big, doesn't the square root of n go to infinity? That's what I was saying. The denominator is getting bigger. So 1 over the square root of n will go to 0. And that's the logic here. All right. Yet again, what do we know? The series what? Converges by the alternating series test. That's not less than 0. Converges. Okay. All right. You guys okay with that one? Pretty simple. Okay, what's going on here? I like this example. Ladies and gentlemen, this is alternating. Is that true? That's my alternating mechanism. Okay, then this portion is what? Bn. Okay. Bn is 3n minus 1 over 2n plus 1. All right, you guys okay with that? Okay, now what do we know? This Bn is going to be positive 3n minus 1 over 2n plus 1. Let me remind you guys here. 3n minus 1 over 2n plus 1. The terms are positive, ladies and gentlemen. But what's the problem here? It's increasing, isn't it? So you might say, Mr. Judge, Bn is positive, but Bn is what? Increasing. Yes. So it does not satisfy the conditions of the alternating series test. Now, does it? Say what? Say no. All right. However, I'll write this down. We can't use the what? AST. AST assumes, it's an assumption here, right? All of this right here has to be satisfied. We're violating the fact that the Bn has to be decreasing, so we can't use alternating series tests. However, that still is going to be helpful to us, okay? Now you might say, why is that helpful to us? What do we use then? Well, guess what? What do you use? Do you guys know? Use the what? What do you guys use? What do you think you can use? in your tool belt? What do you guys have in your tools? What do you guys have? If you look at this sheet and you go, darn, where was that sheet at? I don't know. Here, was it here? No. Is it here? There it is. There we go. What do we have in our tool belt that we can use? Huh? Guess what you can use? Use the test for divergence. This one is big. I've actually toyed with the idea of doing, like, for example, I've toyed with the idea of creating a separate video and worksheet with everything with the test for divergence. Because that's something people forget about. It's in like the first section, 12.2, and they forget about the test for divergence. And they don't know what's going on. So I thought, maybe I should just make a video separately on test for divergence. Whole bunch of examples. This is going to be one maybe, right? You say, well, how does that work? Do you guys remember? Here's how this works. You might have seen this already. You look at this whole thing as what? AN. Do you guys remember what the test for divergence is? What does it say in your summary sheet? Right? What do you guys know? If the limit of the absolute value of AN as n goes to infinity, if that does not equal 0, then what can you say? The series AN what? Diverges. You guys remember that? This is what you guys want to use. Okay, now, I have to look at what now? This is my AN. I need the absolute value, -1 to the n plus 1, 3n minus 1 over 2n plus 1. I got to look at this absolute value. Now, we did the algebra for this already. Let me get some more here. Okay. We did the algebra. Do you guys remember what I'm talking about when I say we did the algebra on all this? All right, let's take a look. Okay. So let's do some algebra now. What's the absolute value of a product? Product of what? Absolute values. Okay. And then what is this over here? You said, what's the algebra here? Well, that's the absolute value of a product. So I have this n plus 1 of these here. And this is just going to be times 3n minus 1 over 2n plus 1, because this portion is positive for all n. Okay, you guys remember that? I'm saying this is positive for all n. So we get to remove the absolute value sign. That's why it's gone. And then over here, you say, what is this going to be? Well, that's really 1 to the n plus 1, which is really 1. So this is really 3n minus 1 over what? 2n plus 1. This is your AN here. So we're going to take the limit of this and see where this goes. Okay? Limit. N goes to infinity. 3n minus 1 over 2n plus 1. Do you guys know what this limit is? It's 3 halves. Isn't that 3 halves? Is that true? You say, how many times have you had to see this calculus 1? Use calculus 1 or use calculus what? 2. This is a calculus 1 approach. You'll find that that limit's going to be what? And is that not equal to what? Is that not equal to 0? Keep in mind, what are we using? The divergence test, also called the test for what? Divergence. So even though we couldn't use AST, we can use what? Test for divergence, and we know that this series, what now? This diverges. What? When it applies. You say, when do I use that? Well, I mean, you got to take the limit of the absolute value of AN. I want you guys to note something as well. Three n minus 1. I'm going to try this out here. All right, let me try this one here. I want you to give you guys a note, by the way. Okay, I don't think this is on my... Yeah. All right, let me give you guys a note here. Okay. I want you to look at this particular alternating series. This is related to this problem we just did right now. Okay, it's related. Good stuff. It's alternating. Here's the alternating mechanism. Here's Bn. Okay? So Bn is 3n over 4n minus 1. This is for all n. Remember, n starts at 1 because this is my index over here, okay? So this is an alternating series. Would you guys agree with that? It's alternating. Okay, well then what does that mean to be alternating? Is my Bn terms positive? Yes. Or is Bn decreasing or is it increasing? Well, I entered that into Desmos. Okay. And what do you guys see? Sure enough, it's decreasing. Is that true? So it's decreasing. Good. All right. Guess what we can use? We can use the alternating series test. We just have to see if the limit of 3n over 4n minus 1 equals 0. Is that right? All right. What do you guys know? What is this limit? 3/4. It is 3/4. How do you know it's 3/4? You can say calculus 1. Right? You guys know what I'm saying? All right. Now, what's the story about this? This is not equal to what? 0. All right. What does this mean? Well, it doesn't meet the requirement for AST. You can't use what? AST. That's what I want to bring home to you guys. You can't use AST. AST is out. So you go, oh my God, I can't use AST because AST requires that limit to be 0 in order for you guys to conclude what? Convergence by the alternating series test. Remember I said this portion right here has to be satisfied for your conclusion of convergence. Can't use AST. So then you sit there and you go, oh my God, I'm so frustrated. I hate series. And it's because you forgot something. What did you guys forget? Check what? What's the test for divergence? Use the what? Yes, use the divergence test. I'll say that. Now, you might say, what is the divergence test? We have to look at the absolute value of AN. That's the absolute value of this whole thing now is thought of as what? Your AN now. This is AN. Okay? So I want to point this out to you. AN is negative 1 to the n, 3n over what? 4n minus 1. Use your properties of what? Absolute value. Now, at this point, we said, Mr. Judge, I think I understand a few things here. This is what I mean. I understand you'll tell me that this portion here is positive for n being 1, 2, 3, 4, 5, whatever. I get to remove the absolute value because it's positive. And I already know the absolute value of negative 1 to the nth power is going to be what? 1. I know that already. Can I use that? Yes, you can. So that means now the limit as n goes to infinity now of the absolute value of AN, which is really what you're having to check. 3n over what? And what does that equal? 3/4. Is that not 0? It's not 0, ladies and gentlemen. This is necessary to be required to use what? The test for divergence. If the limit of the absolute value of AN is not 0, what do we say? That's divergence by the divergence test. See what I'm saying? It isn't so bad then if it didn't satisfy the criteria. So we can say this actually diverges equals to infinity, which means diverges by what test? Notice how I'm citing my what? My test. I'm justifying. I am showing I know what I'm talking about. So on a test, what do you have to do? Show your work, because what are people going to do? They're going to guess. Convergence. Divergence. Oh, it's clear. Take a look, Mr. Judge. It's clearly that diverges. They never show any work. Because they're what? They're guessing. You got a 50-50 chance. Convergence, divergence. You see what I mean? So I put on the test, show work for credit. What do you think you have to show? Look at what I'm doing. Isn't that work? Yeah. So don't guess. All right. What do you think about that? All right. Let's look at the next one here. Alternating series test. Is that right? And what's my BN? It's an alternating mechanism. BN's going to be 1 over what? 3n minus 1. Okay. What do I know about Bn? It's positive for all n. And is it decreasing? It's decreasing. Yeah, it is. Is it getting smaller? The denominator is getting bigger. The numerator stays the same. So 1 over something getting bigger is getting smaller. We could look at the graph. But we won't. Limit. N goes to infinity. Bn. The limit. Bn is 1 over 3n minus 1. What does this go to? Can that go to 0? Okay, what do we say? This series what? This series converges by the what? By AST. Okay, you guys okay with that? So I'm going to go in and out here, give you guys more examples. Clearly an alternating series because you got the alternating mechanism. And then you got this Bn. Is that true? So my Bn is going to be what? N e to the minus n. So this is n over e to the n. Here's that Bn. All right. So I know my Bn is positive. Is Bn decreasing? Well, the answer is yes. How do I actually know? Well, I can use calculus. I can say my numerator is increasing, but so is my denominator. Is that true? Which one's increasing faster? The denominator. So you can kind of show that this derivative will be positive, okay? But more, let's take a look and show you in Desmos here. What do you guys see? Isn't it getting decreasing? All right. Then what should we do? Then we could look at the limit now. Is that right? What's the limit? As n goes to infinity, n over e to the n. Uh-oh. Infinity over what? Infinity. See my point? Oh, so it's infinity over infinity. I guess I'm going to have to really look at the limit of what? I'm going to have to go to calculus. I know the limit is x goes to infinity, x over e to the x. I got to look at a real numbered value because using L'Hopital's rule and taking derivatives, ladies and gentlemen, requires the function to be a real variable x, not natural numbers. Okay, you see what I'm saying? Can't be natural numbers. What's this limit? 0. Nice. So guess what? Can we use the alternating series test? Yes. Yeah, we get what again? Converges by AST. So those are the things I'll be looking for, not guessing, hey, convergence, divergence. You got to show the what? The work on this, okay? All right.
Mister, do you want us to write down it's convergence via AST or test
yeah, I would like you guys to do that. Yeah. Okay. But don't just guess and then write that down. Show the what?
Completely wrong.
Show the work. People go, hey, I'm going to guess by the test now too. No, you don't want to guess. It's about skill. That's why I mean show your work. I'm going to do some more of these here that I have, stewardish kind of questions, 1 to infinity, and cosine n pi over 2 to the n. Okay. Sorry, I'm good. You guys can get started on that. All right, let me remind you guys something here. You know what cosine n pi is? Yeah, this is alternating in sign. It's an alternating mechanism. What that means is Bn is going to be what now? N over what? 2n. And this thing is positive for all n. And I'm going to say to you guys, how do I know this Bn is decreasing? You can look at the function x over 2 to the x and show that first derivative is negative on the interval from 1 to infinity here. Okay? But how do I know it's decreasing? You know how I know? The numerator is increasing, but what do we know about the denominator? That's also increasing, but it's exponential. Exponential growth is the fastest growth that we have. So the denominator is increasing fast. The numerator is increasing. What's winning out is the denominator. All right. You say, I got to see this here. You're kind of looking at a picture of it right now, but we got to change the base here. 2 to the what? X power. Okay. So, yes, you can say when x is 1, what's going on? Is that 1/2? When x is 2, it's also 1/2. So we can also start this at 2 versus 1. So here's what I'm saying to you guys, so you guys can see. Take a look at this. Okay. In this example, this is going to be true only starting at what? 2. 2 to infinity. So you might say, well, how do I fix this situation? Okay, when x is 1, I got 1/2. What's the sign of cosine of 1 pi? Negative. Now, say start at 2, go to infinity for this problem. Okay. And now you can have n cosine n pi over 2 to the n. And ladies and gentlemen, that first term being negative, it's a finite number. So if you get infinity for the sum, it's still going to be divergent. If you get finite for the sum, it's still going to be convergent. This is what I'm saying. This number, because it's finite, is not going to influence the outcomes by the AST test or any other test. All right, we got to take now the limit now. Is that true? The limit of what? Bn is the limit of 1 to 2 to the n. 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 1 to 2 to the n n over what? 2 to the n. What do we discover again here? Oh, darn, we got to go to calculus 2. What do we use in calculus 2? L'Hopital's rule. Change the variable to x because the domain has to be over real numbers. What's the derivative of 2 to the x? Do you guys know?
2 to the x, Alan.
Yeah, ln 2, 2 to the x. Ln 2 is a constant. So I can pull out my constant, take the limit as x goes to infinity of 1 over 2 to the x. We know this thing goes where? 0. You go, how do I know? Because the numerator is constant, denominator is 2 to the x, exponential growth. 0 times 1 over natural log 2. This is going to equal what? 0, which means this equals 0 as well, which satisfies the alternating series test. That means we have what? Convergence here, finite number. Ow, we don't know the sum though. We don't know that sum. AST doesn't tell us the sum, but a finite number minus 1/2 is what? Finite. So this converges. It's all the gory details. All right, let's do one more here. Let's get a good one in. All right, got to get a good one. Those are good, but I can send you a video of the rest of these later on that worksheet. Okay, giving you extra examples. Do you guys like extra? Do you guys find it helpful? Or am I just wasting my time? Because my wife gets pissed. So, Daniel, you're home. I need you to talk to me. Say, sweetie, I'm sorry, but these kids need some of this work. I got to send it to them. You don't understand. They need this stuff. I don't know. Maybe I'm wrong. Maybe I said, no, I don't care, Mr. Judge. Spend time with your wife.
I will.
Huh?
I will.
You'll what?
I will spend time with my wife.
You choose your wife over kids? Say, Mr. Judge, I'm not a kid. Well, if I'm older than you, even if it's by only a year or two, you're still going to be a kid in my eyes. I apologize if I offend you. All righty. Alternating. And then you go, is this my BN? Mm-hmm. Let's BN. Okay. I believe n is 1. Bn is positive for all n. But is Bn decreasing? Oh my gosh, what is this? I can use calculus. That might take me a little long. What do you guys think? We don't have a lot of time. Oh, thank you, Desmos. What do we know about this? It's decreasing. Good. No wonder it's in the section of AST. Bn is what? Decreasing for all what? And okay. So you say, what's the limit now? As n goes to infinity, square root of n plus 1 minus the square root of n. And you say, infinity minus infinity. Okay. You're going to now have to take a look at this as a function of x. Why do I say that? because you have an indeterminate difference here. Okay, an indeterminate difference. What do you have to use when you have an indeterminate difference? Well, yeah, I mean, I guess we can do, we don't have to use Lapido's rule on this one. This is actually a Calculus 1 question. Remember this in Calculus 1, the indeterminate difference? All right, there's a way we fix this. Let's use some algebra. You guys remember the fix? No. You got to multiply top and bottom by what? Yes, the conjugate. Thank you. I am glad you took Calculus 1. Thank you for taking Calculus 1. And it's plus. I guess those prereqs help. X plus 1 minus x over, what is this? Square root of x plus 1 plus the square root of x. What does that equal? 1 over square root of x plus 1 plus the square root of x. Okay. All right, ladies and gentlemen, this is the limit that we need to look at. And we could go back to n because we're not using Lapido's rule. We're just using algebra. What's this limit? Do you guys know? 0. Good job. This limit is 0. And if that limit is 0, ladies and gentlemen, this limit is what? 0. So we can use the alternating series test. What does that mean here? This series what? Converges y? AST. Anyway. So, I can go through these examples all day long. In fact, I got a whole bunch of good ones to do. Again, when I get home today, I'm not going to talk to my wife tonight. In case you guys appreciate that, I'm going to what? Work on some more of these examples and send them to you guys because I just can't help having fun doing the alternating series test. And I might even send you, what else can I send you? Some of the lectures from like maybe last time I taught the class. Actually, I have a website, an old website that has some more examples of all these. So, I can do that too. I was thinking about that, but I don't know. I might be knocking you guys on the chops there. And you're like, dang. Am I oversaturating you with extra examples? I don't know. I hope not, but I wish I had this when I was a student. I'll tell you that. If I would have had this when I was a student, oh man. And then it's free. You know what some of those instructors are doing? They had a meeting with a publisher to have calculus resources that they're going to charge you for. They'll make you pay for them. And I say, don't do that. Make your own resources. It's not that hard. I guess they rather talk to their wives at night, I guess, or their husbands. Because they're not going to do it. But my stuff's going to be there free forever. Spread the word. Put it on TikTok, Instagram, free. And, you guys will get extra examples here, okay? You don't have to pay a publisher all this money for something that's available for you for free. And if you say your prayers, include me in your prayers. All right? All right. Do we have class on Monday? No. When is your test 4 due? Good. June 2nd, 9:30. Good. Could you turn it in earlier if you're done? Like maybe you said, I'm going to spend my Memorial Day doing homework. Yes, you can. You can turn it in any time. Don't use the tutoring lab. Don't do that kind of stuff. All right? Because you're going to have to do this on your own task. You got to think. You got to go through the tools and examples that I gave you guys. Use what here? Use this guideline because you're going to use that on your test. That's what I would do. I mean, your final. Yeah, on your final. Well, you could use it on your test too. Test 4.
Yeah.
I mean, that's, yeah. Does that make any sense? It's going to be what's on the study guide. I can't give you everything we covered. I wish I could. Can't do it. It's only a 2-hour final, not a 2-day final. And then I have to grade it and read it. And that's the worst part. Because sometimes you read things like people will put answers upside down and backwards sometimes. You're like, what? I can't read it. It's hard to read. Can be. But hopefully you guys do what I'm doing on these on the demonstration. You know what I mean? You want to go through it this way. That's what you're looking at. Just the work. That's why you have to go and read the work. That's why when I grade it and give partial credit, I have to look for certain things to give that partial credit. You see what I'm saying? If it's not there, I can't give partial credit. So it puts me in a dilemma if I don't see anything even and stuff. And you're like, how do you deduce convergence with this? It's not there. That's why you want to show your work. So anyway, ladies and gentlemen, I hope you guys have a good Memorial Day. Take care, stay safe, and have a wonderful weekend. Right? Do your homework. Number 5. We have our alternating mechanism. And we have b to the n here. So if we take a look at b to the n, 2n over 4n squared plus 1. Remember, b to the n is positive for all n. And what we can see is the denominator is getting bigger faster than the numerator. So this is going to suggest that bn is decreasing. So 2n over 4n squared plus 1 and as you guys can see in Desmos, that's sure enough exactly what's happening here. So we got a decreasing series. All right, good. Now, as we look at the limit of bn, which is the limit of 2n over 4n squared plus 1, we divide by every term by n squared. Using, again, the calculus 1 approach, which gives us 2 over n, 4 plus 1 over n squared. We're going to look at the limit as it goes to 0. The numerator, or we should say, by properties of limits, this will go to 0, this will go to 0, so we really have 0 over 4 plus 0, which will be 0. Okay, so the limit here equals 0, and that means we satisfy the assumption that Bn is positive, Bn is decreasing, the limit is 0, so we have convergence here by the alternating series test. So we have convergence. All right. Number 6. We got the alternating mechanism. This is Bn. So Bn will be the square root of n over 1 plus 2 square root of n. All right. So what we can see is the terms are in fact positive for all n. And again, the numerator looks to be increasing faster. Sorry, the denominator is increasing faster than the numerator. So the terms are decreasing. So if you want to check Desmos, we have an issue here. Does not look like that is actually happening. Okay, we got a problem here. This Bn terms are in fact increasing. So this does not satisfy the assumptions that we need. We actually can't apply the alternating series test in this case. So then you say, well, what do we do with this if we can't apply the alternating series test? It doesn't apply. I'm going to say, consider the divergence test. So in that case, this whole series here we're going to look at as AN. And we need to consider the absolute value of AN. So the absolute value of AN is the absolute value of negative 1 to the n square root of n over 1 plus 2 square root of n. All right. So we're going to use some algebra here with absolute values. Absolute value of a product is product of absolute values. This is 1. All the terms inside are positive because n is natural numbers. So what we're seeing here is simply that the absolute value of an is the square root of n over 1 plus 2 square root of n. Okay, so as you apply the limit to the absolute value, that's the limit of square root of n over 1 plus 2 square root of n. You're going to take now that square root of n, divide every term by the square root of n. Okay, just like you did in calculus, 1. So you get the limit now of 1 over the square root of n plus 2. N goes to infinity. This will go to 0, which means your limit actually goes to 1 over 0 plus 2, which is 1/2. That limit is not 0. So if the limit is not 0, then that means by the divergence test, this series diverges. So we have a divergent series here. So we can say equals 0. It diverges by the test for divergence. Okay, there we go. Number 7 here. You got the alternating mechanism. We got our Bn. Okay. Bn is e to the 1 over n over n. Bn is positive for all n. And Bn, let's see if this is increasing or decreasing now. So that kind of makes sense that we have a decreasing series. So Bn is decreasing. You can probably use calculus and show that the first derivative is negative over the interval from 1 to infinity. Okay, we just looked at the graph. Now, let's look at the limit of Bn and see where this goes to. Now, what do we know? As n goes to infinity, 1 over n goes to 0. E to 1 over n goes to e to the 0, which equals 1. So your numerator is going to 1, while your denominator is going to infinity. So that means our limit, because remember, n is getting big, it's the same n, 1 over something getting big is 0. That's the limit value. This is approaching 0. So this equals 0, and it satisfies the alternating series test conditions. Therefore, this series converges less than infinity. Converges by the alternating series test. Okay. Alternating mechanism, b to the n. B to the n is natural log n over n. And yeah, it looks like these terms are going to be positive. So you can say Bn is greater than 0 for all n. But the natural log, which one's increasing faster, the natural log or n? I think n is increasing faster than the natural log. But if we take a look at this, yeah, we start to see how this series really behaves. And I'm going to say you're increasing at 1. At 1, it's 0. And then at 2, it's larger. Starting at 3. So at 3, we will be decreasing here. Okay? You guys can see that there. Starting at 3. So really, what's happening with this series, you can say, well, 0, now n is 1. Well, this is when n is 1, we get 0. N is 2 now, we get negative 1. I take that back. Let me go back here. We're looking at this term here. So we really want to look at this starting at 3 to infinity. I think it's very easy just to kind of remark here that now for this series, it is positive, but b to the n is decreasing starting at 3. So from 3, n equals 3. Okay, and it turns out that's going to be good enough because we really don't care about the first two terms. They're finite, so an infinite value plus a finite will still be infinite, and finite plus finite is finite, so we're still okay. Just want to point that out to you. Now, the limit of Bn is going to be the limit of the natural log of n over n now. Okay, so n goes to infinity. That means we get infinity over infinity. So we're going to have to consider this as a function. If we look at the function now, natural log x over x, and we look at the limit now, as x goes to infinity, natural log x over x, we still get that indeterminate quotient here. So because it's an indeterminate quotient, IQ for indeterminate quotient, we're going to use L'Hopital's rule. And now that means we get the limit as x goes to infinity of 1 over x over 1, which really is the limit of 1 over x as x goes to infinity, and then we get 0 here. All right. So that means that this limit equals 0, and we satisfy the terms of the alternating series test. So that means we get convergence here, which means we get convergence here by the alternating series test. We're just taking a finite number, whatever that is, and adding or subtracting a few more finite numbers. So this series converges. Okay. Okay. So we actually have another alternating mechanism. And what that means is Bn is 1 over n factorial. Well, these terms are positive for all n, and they are decreasing because the numerator is constant and the denominator is getting bigger, because n factorial, if you guys recall, by definition is n minus 1, n minus 2, down to 2 times 1. All right. So let's take the limit as n goes to infinity of b to the n, which is the limit, as n gets big, over 1 over n factorial. Now this is going to be 0 because the denominator is just getting bigger, bigger, and bigger. The numerator stays at 1. So this goes to 0. So it satisfies the terms of the alternating series test. So this thing converges by the alternating series test. We get convergence. Okay. Number 10, you have the alternating mechanism. Here's our Bn. Bn equals cosine pi over n. Okay. Well, I think we have an issue here, maybe. Cosine pi over n. Take a look at what's happening here. Well, let's take a look over here. Can't get out of there. Okay. So pi over n, let's take a look. Pi over x. So this is actually decreasing, but we want to know, what about cosine now? Just what I thought. Yeah, pi over n is decreasing, but cosine of pi over n, not necessarily the case. In fact, ladies and gentlemen, that first term is -1. Second term will be 0. Because you got cosine pi over 2, and then all the other terms are going to be increasing here. So what I want to remark is we cannot use the alternating series test because the assumptions that Bn are positive for all n, not necessarily true, but starting at 3, it will be true. So we know Bn is positive for n greater than or equal to 3. However, it's not decreasing. So Bn is actually increasing. So we cannot use the alternating series test. Take a look at this again, just to emphasize that. All right. 1, 2, 3. Yeah. Alrighty. So you might say, what do I do now that I can't use the alternating series test? I'm going to say, try the divergence test. I was going to write down test for divergence. So we're going to now look at this differently. We're going to look at it in terms of the absolute value now. Okay. So the absolute value is defined to be -1 to the n cosine pi over n. Now, using some algebra, absolute value -1 to the n, absolute value cosine pi over n. I think this is 1. And we got the absolute value of cosine pi over n here. We're going to look at the limit here. So let's think about this here. What do we know? As n goes to infinity, cosine pi over n goes to cosine of 0 because pi over n will go to 0. So let's write this in order. Cosine of 0 is 1. So this limit will go to the absolute value of 1, which is 1. Okay. This is not equal to 0. So by the divergence test, this series diverges. Now, we could have actually seen that from the beginning without going through the test for divergence. We could have taken a look at this and said, okay, well, we're going to leave it at that.